Hello everybody, this is Nick Losi and Caleb Unger. This is our third video doing digital simulation class, and in this video we'll be covering policy and decision making. So this is the problem description, but we're going to go into it a little bit more. You can pause on here if you would like. Alright, so we're giving the current problem of having a machine tool with the life, distribution, time to failure, density as given. So we know that 4 years from now we want to scrap this part. We want to run 5,000 simulations of 2 different policies to see which one is the most cost effective. So the first policy here, we are replacing the part whenever it fails over the 4 years until it's scrapping time. Now the second is different from that in that we're replacing the failures during the first 2 years and then going to make a preventive replacement 2 years from now. So following that preventive replacement, the part is replaced on failures occurring during the second half of the 4-year span. So we're going to find what point are the 2 policies the same and what's the relationship between cost of prevention and failure. So here we are in MATLAB. We're looking at policy 1 and we're going to do the 5,000 iterations. So we want to count the number of failures that occur within each of these simulations. So while the year is less than 4, we're going to be generating 2 random numbers that are going to be used in the log distribution. So if it's past year 4, we're going to stop counting the number of failures. However, if it gets past that, we're going to add that to the counter. And then we're going to divide it by the number of iterations to get the mean number of failures.
So going into policy 2, we see that our iterations are doubled because we cut the lifespan of counting failures in half to 2 years, which you can see down in the if statement. So if it fails past 2 years, we're breaking the statement and not counting those number of failures. But it's the same process in terms of calculating the failure rate, and in the end, we're trying to get a mean number of failures for the policy 2. Ultimately, at the end, we're going to get a ratio of the mean number of failures to the iterations that we ran. And after rearranging the problem that you see up top with preventative cost along with the failure cost, we can solve for the break-even point, basically, which we come to find out is about 25% of the failing cost is the preventative cost. So if the preventative cost is less than 25% of the cost of failure, then we're going to go with policy 2, but if it's greater than that, we're going to stick to policy 1. Thank you for watching.